It's a pleasure to introduce Jack McCauley. Jack is an innovator in residence at the Jacobs Institute for Design and Innovation, where he mentors students, lectures in courses, focus on product design and design for manufacturing, and leads research and development projects focused on applications of augmented, virtual, and mixed reality for design professionals and students at the Jacobs Institute at the University of California, Berkeley. Dear Dr. Jack McCauley, welcome. Join us on stage. It's a pleasure to have you with us. Thank you so much.
Thank you. Yeah. I brought a slide deck with me. As he stated, my name is Jack McCauley, and I'm currently working. I've got a private R&D facility. I got rid of it. It's much smaller now. I'm currently working on stuff, and I do teach at UC Berkeley often. We built a makerspace on campus. I did when I left Oculus VR. We sold my company and some other guys, and we sold it for $3.2 billion to Facebook. I used some of the funds to build a makerspace on campus, and I'm the innovator in residence there, so. Today's talk is about video games. I spent 40 years working in entertainment. I worked on video games, some good ones, some not so good. The last place I worked was Oculus VR, and that was a commercial company we sold. Okay, this is a little bit. Is a well-known American inventor, engineer, and has worked on a number of high-profile products in the tech industry, actually in entertainment. He is perhaps the best known for his work in Guitar Hero. I was the head engineer on Guitar Hero, which is a plastic guitar video game. That was 20 years ago, today, almost today. He's also worked on projects for Microsoft, Electronic Arts, all of the major video game companies I worked at, Activision, so forth. And my job consisted of making sure the hardware part of it got done properly. That was the hardware engine. So the tooling, assemblies, all of those things, that was my job. I did the design work too, but mostly making sure that stuff got built. I built the first 3 headsets for Oculus in China, South China. So this isn't exactly true. It's okay though. I am the inventor of this. I'm an inventor also. I do the inventing stuff and then I produce it. The scrolling wheel mouse, that is from the late 80s. That's 87. And the X1, that's special. Got lucky, kinda, but I also, it's not because I'm that special. Got lucky, kinda, but I also worked with that special. Got lucky, kinda, but I also worked with good people special. Got lucky, kinda, but I also worked with good people. The guys that started Guitar Hero, kinda, but I also worked with good people. The guys that started Guitar Hero were two, kinda, but I also worked with good people. The guys that started Guitar Hero were 2 brothers, but I also worked with good people. The guys that started Guitar Hero were 2 brothers, started basically in their garage. They later moved to an industrial space. They were from Taiwan, and my ability to get along with them was not so great sometimes, but because I had a good relationship with them. Later on, he got me a trustee position at UC Berkeley, one of the brothers there. He elected me. So that's how it went down. It's just a small community of people and working on entertainment. It's not very big. It's not like automotive. I kind of know a lot of people, and when a gig came up, I would get hired. So, career credits. Chief engineer and co-founder of Oculus VR, chief engineer on Guitar Hero. I worked on feature films. I worked on Terminator 2, Dick Tracy, Edward Scissorhands, the technical contributor. And I worked on the audio system. I spent 40 years in entertainment, as I mentioned, and professor at UC Berkeley, innovator in residence at the makerspace Jacobs Hall. Rand Corporation, not so much right now, and then a Math and Science Research Postgraduate Institute on campus, Berkeley. So again, it's because of people. The guy that got me the gig at MSRI, the Math Institute, I worked with him at Kodak Research. And I stayed in touch with him. I'm a phone call guy, I'll call you. How's it going? What are you doing these days? How's the family? Blah, blah, blah. And they remember that. The next time a gig comes up, I get the job. How it went down. And I could do the work. This here, these are cars I built. I build cars, it's my hobby. And that's a Fiat 500. You from Portugal, people from Portugal are familiar with that car. And I put a motorcycle engine in it. I just finished this. It's not quite finished, almost finished. The thing is, I want to be able to drive it on the highway, and you can't. Stock car is horribly underpowered. It's only at 19 horsepower. So you're the one holding up traffic. So I squeezed a motorcycle engine in. I bought a complete ZRX 14, 215 horsepower motorcycle engine and put it in there. The top one, I finished that in 2010, the orange and silver one. And that's got a Rolls-Royce V12 in it. And the one on the right is a Lola T70 Mark IIIB. That I finished. I built these, my staff and I did. So that's what I do. I also, as part of my job at Berkeley, I'm also working on EVs. They like electric vehicles. I've got a couple of them. I teach that actually, not so much the contract manufacturing stuff, but this is, I mentioned this to someone earlier today, but you've seen these drones, right? Attacking people out in the battlefield. They put a munition on them and they fly them into people. Well, this was in 2019. I finished that thing, and because I saw it as a threat, and I was right, but I didn't do anything with it. I tried to sell it at one point to the military, and then I just didn't want to deal with the military bureaucracy stuff, so still have it. But it's for taking out drones that are attacking people. That's what it's for, and it works. The reason I did this is one of the guys I worked with got into a fight with one of the other co-founders who took a drone and flew it into his beach house. It was positioned above his bedroom window. And he goes, I'm going to get a shotgun and shoot it. I go, don't do that. So that's what I built that for, to get rid of those threats. And it works on the DJI drones, the popular Chinese drones, and things like that. It works well. It also can jam Wi-Fi, the jammer. And this is a calculator I built. It's a copy of a calculator. And this is a really, really interesting device. It's Jonathan Napier, a mathematician, designed this, but it actually goes back further than that, to maybe the time of Greeks, but allows you to add and multiply huge, gigantic numbers, 10 to the 20th, just by turning these bars here. So I like the thing so much, I decided to make one. I made that, and I have it. I just don't play with it. It does long division, square root, cube root, all those things for math, basically. So. Okay, I'm going to try to play this here. This is what I worked on this year, and I'm going to explain some things to you, and I'll try to make sense of my presentation here. So let me see if I can start this. There you go. No audio. That's okay. So here, this scene right here was done on a Sun workstation, pre-GPU. There was no graphics processing units back when we had 20 Sun workstations cabled together, and it took 6 weeks to render that. Right now, you can do it instantaneously. It's a really good movie, too. I was surprised. James Cameron is the director. I was really surprised. I like sci-fi. I was really surprised at the quality of it. And also the renders. This was in 93, 92, 93 that they were doing. Anyways. Go to the next slide. Come on. Okay, this is from 2023. It's a game called Record, and that's from 1993. And I'm going to explain something about that, what a GPU is and what the power of a GPU is, because it has a lot to do with AI. Let me play this. The one on the right is 93. The one on the left is 2023. It's photoreal almost. And this is in real time, playing it in real time. You're the police avatar here, and you're walking around a room, you can change direction and so forth. Sorry about the violence. It's a violent game. Look at the one on the right. The one on the right's that's a friend of mine who wrote that. And that was running on a really, really inexpensive 8086 machine, an IBM PC. And what makes this possible in 2023? I'm going to explain some technical stuff to you, and it's not very technical, actually. I'll just explain how computers multiply numbers. They take a number, and it's called an integer. It has no decimal point, and you can multiply another number without a decimal point together. You can multiply those. If you want numbers with a decimal point, it has to use a library, a software library to do that. In the 90s, until later on. So a flop is a floating point operation. It's called floating point, the one with decimal points, right? It's the index that's used to measure computer performance, called a flop. So back when I started this in late 80s, working on this stuff, 45 years, you probably could get 1,000 floating point operations per second, one every thousandth of a second at max. Okay, so computers don't do floating point operations well, but new computers, your phone in my pocket here, it's an iPhone, it has a floating point operation coprocessor called a GPU, got one in it. And so, why am I saying this? I'll get into it in a second. They like integer math. So this was the first math coprocessors that could do floating point operations. It came out in 89 to 83, 87. So when you bought a machine back then, it had a floating point coprocessor on it, and it had an integer processor for doing the disk reads and so forth like that. Why is this remarkable? Because this thing is not actually done with transistors. It's another computer inside of it. It's a dual computer thing. So they call it microcode. So that's the way this thing worked. But this game you just saw, the one made in 92, wouldn't have been possible without this thing. It's also when NVIDIA was founded. NVIDIA makes GPU, graphic processors, do the kinds of CAD. It did 170,000 floating point operations. So in 4 years, we went from 1,000 floating point operations to 170,000, starting in the late 80s. So that's NVIDIA, founded in 93. By 1999, they were doing 4 billion floating point operations. 4 times 10 to the 9. And in 2000, the PS2 was doing 6.2 billion floating point operations per second. Now, the PS2 is an old console. So we relies on this thing called a GPU. The GPU does shading and rendering, what its job is, real time. So graphics coprocessor is a chip that does large math operations very quickly. It resides on the console motherboard. Console is game console, PS2 or whatever. Most video games use a GPU to create rich graphics in 2D and 3D, and the rich graphics use a large amount of processing power to create the effects. We, at Oculus, when we built our headset, it did not have a GPU, and it had an HDMI cable, video cable plugged into it. It wasn't a standard first one. So people think that it had complex electronics in it. It didn't. Electronics. And without video games and entertainment pushing the boundaries of computing power, there would not be the kind of advances either. Because the chip that runs AI is called a tensor processor, and it's a GPU kind of way. It's the type of math it does. So let's take a look at performance here. Okay, the Intel ASCII Red 2000 was doing 1.4 trillion floating point operations per second back in 2000. Okay, and there's other ones on here. Xbox 360's about 20, something like that. So 20 billion. So let's take a look at something here. The next slide. I'm sorry, this is a little blurry. I wear glasses. iPhone 14 Pro. Look where it is right now compared to the other things that are there. iPhone 12, iPhone 8, and it's even more powerful than the Sony PlayStation. This is the advances. So when I started looking at this, like, where do you do your AI? Where's it done? Well, for the most part, it's a service purchase. It's sitting in a data center somewhere. Intel or Microsoft, someone like that has the capacity. run AI. So you use a service. But then I'm seeing the Sony iPhone 15 running rich graphics. And how's it doing that? Well, it'll do it, but it gets hot really fast. It generates a lot of power. But that's where we are today. Can you do AI inside of an iPhone 14? I'm not sure you can, or a 15. I'm not sure you can. You use a service. So this is 2023. So this one does 110 trillion floating point operations a second. This is what you need for AI. That's where we are years ago. I think it's probably current. So I'm going to explain something about math guy. I'm not like a math professor, but I like math. So see this equation? And the answer is 2, of course. And then what is algebraic value of x? X is 2. What the GPU does this kind of math, does a matrix. Some of you know them. Takes these huge matrix numbers, does operations, multiply, divide, so forth. Mostly it does multiplies. This is the key to AI, mathematics. And you have to train the network. Sure, there are people more than I am sure, probably. The neural net has interior connections, synapses that must be trained. You train it. You have to tell it what error you feed it back. Self-trains. It's all back propagated. A neural net's must be trained by human input or other expertise. And the math operations today are some math opposites. The point of my talk here today is that I attribute the advances in AI not to the math. The math's been around 40 earlier. It's the performance, the computing performance, sorry. That's a neural net. I took AI courses through the extension, university extension in the 90s. I didn't know anything about it, didn't think, how does it work? So I took all these courses. And later I started using not a neural net, but an artifact of AI, a field of AI, and some of the stuff I was doing because it was a lot easier. Trying to do it, writing software, data structures, and so forth. It just didn't work very well. So the TPU is a tensor processor. It does large matrix operations. It's like a G. That linear algebra stuff I showed you, that's what. And there's multi-cores. There's maybe 25 cores or 30 core processors on board TPU doing the work. This is what NVIDIA does. And you know what's interesting is like we were working with those guys in 2012 on VR, NVIDIA. I didn't know Jensen, but my boss did. So I go in there, and it's just this little building. I'm going, where's the rest of it? Well, they do their manufacturing in Taiwan. And now it's a huge campus, gigantic. Central Avenue in San Jose, California, just goes on and on. And this is the revenue they're getting from this stuff. Used also with the TPU stuff. And I make the argument that it wouldn't have happened without video games because the cost has to be low. You have to have low cost for people to buy it. They make their PS2 console was $310. How do you do that? Well, selling at cost, but it still has to be cheap. And that pressure on the economics of entertainment or video games was because people wanted to play video games. They wanted to be, because the people that are playing, they're in their 20s and 30s, demographic for games. And thank you. And I have time, I think, to take some questions. Is that correct?
So questions.
Thank you.
Who has a question for Jack? I do. Anyone else? There we go.
Hey, a great talk. This is not really a technological question, but certainly relevant to AI. And if you're like a 5-year-old or a 6-year-old of a parent, if you're a parent of a young child or whatever related to a young child, what would you say to a child? Like, what could they be in the future? Because like AI and robotics is pretty much going to do almost everything that we can do. So like, is there a future for our children? kind of a basic question.
I don't think it'll be putting up sheetrock and drywall at your house or painting your house. It won't be doing that. Those jobs will always be there. Customer service support is going to go away. It'll go away eventually. Not right now, but it will. It's already kind of doing that a little bit. So I think the impact on, I heard this also, that it's going to take software engineering jobs around. I don't think so. Too difficult to teach it to do that. And writing a computer program is a lot like writing a book. It is just like that. I mean, it's different, but it is not different in a lot of ways. It's a large amount of work, big one. It's a large amount of work, and it has to progress through. I just don't see that happening. That answers the question. Customer service, I think, will be impacted greatly. People, banks of people sitting in a room on phones are probably going to go away. Anyone else?
Hi. My question came because we saw the clip of Terminator 2. So you've been in the entertaining industry and you see now the technology of making CGI and more digital visual aids. Why does it feel that for us, when we see, I'm going to take the example from Predator, because they made now the teaser of the new movie, and the Predator looks absolutely worse than the first one that came out. So what do you feel about that?
Well, you're looking at an animation, and I think the first Predator was a guy in a suit, guy in a suit. So that's the difference. I would make the argument Terminator 2 did a really good job with their CGI. I think they did. It was spectacularly good. For the time, it was groundbreaking. You got to realize it like 26 Sun. There used to be a company called Sun. I think they're out of business now. Sun Spark stations linked together in a room with engineers, and it took forever to render that. A long time. So now you can do it in real time. I'm not sure it'd be quite that quality, but pretty close. So, hope I answered your question.
Yeah, so we're going to have to finish, although I'd love to continue, Jack.
Thank you.
But before you do, thank you so much for being with us here today. I mean, the work you're doing at Berkeley is absolutely phenomenal. It was pretty clear over here, and it's inspiring to see how computation is really, coming to a level. And I was looking into the slides that you showed in the video. When Jack showed the video of the 1993 video game and the 2023 video game, that's 30 years difference. The question is, what will it look like when Jack brings the 1993, 2023, and 2053? What happens when you extrapolate the change going from 1993 to today, and you went from, a set of squares and nearly undistinguishable reality into another 30 years?
That's also done in real time.
Let me give you another. Oh, it's there?
In real time also.
Yes, and not just the resolution, but the real time, the timing frame that it's doable, right?
I saw the whole thing unfolding when I worked in entertainment. I saw the whole thing unfolding in front of me. It just got better and better and better. And by 2000, it was really good. Forza and, I'm sorry, not Grand Theft Auto, I forgot the name of the game.
But you did see the whole... the whole history unfolding, and you were able to see that in 2025 we would have...
So nothing happens for a long time, and all of a sudden there's this boom, and nothing happens for a long time. It's not like it goes linearly. Like
you see it emerging. The same happens with AI. It's very interesting that you mentioned that. The same happens with artificial intelligence. Suddenly, we have ChatGPT. Everybody's asking, how are computers so smart?
Yeah.
In 1996, computers won the best chess player in the world. So who's the best chess player in the world since 1996? A computer. Who's the best Go player, the most complex game ever created? Who's the best Go player in the world since 2011? AI, but nobody noticed. Who's the best Jeopardy player in the world? Jeopardy is, for those who don't know in the US, it's like a real-time conversation with an interview, and questions were very challenging. IBM won with IBM Watson, won the challenge and surpassed the best Jeopardy player in the world in 2020, I believe. So AI didn't just, as Jack said, AI didn't just came out of nowhere. Those on the field saw AI coming very clearly. But only when ChatGPT became a reality, people realized, oh my God, computers can talk to us, and we cannot distinguish this from a real person, right, Jack?
That's correct.
Yeah. And you saw this happening not in AI also, but in the GPU section, the computing. Yeah.
Like I said, it was nonlinear. 89, when the 83, 87 came out, it was a little okay. That was for spreadsheets, more or less.
Yeah.
And all of a sudden, just boom.
Yeah.
In 4 years, 5 years, it started taking off. But whoever invested in NVIDIA back in the day, I'm not sure who their capital investors are. Man, they made out pretty well.
Yeah. That was a very good bet.
Yes.
That was a very good bet. Jack, thank you so much.
No, no problem.
Brilliant talk. Thank you so much. Thank you again. Thank you. Ladies and gentlemen, Jack McCauley.